The MK-01 phase protection relay from ENTES prevents failures in 2 phases of 3-phase motors. It is a phase protection relay, not a phase sequence. Okay, let's start our review. Now this protection relay is a phase protection relay used to prevent failures in 2 phases of 3-phase motors. If you look at our previous videos, we examined a relay called the phase sequence relay. I'll put the link in the description so you can check it out. This relay does not perform phase sequencing. It is specifically designed to prevent the motor from operating in 2 phases. Now there are a few different types of these relays. If we take a look at the diagram here, now there are a few different types of these relays. If we take a look, the diagram right here, let me leave it like this. Ours is just the MK-01, not the MK-01P. So there's also a model that has a PTC connected to it. Ours is not like that. The PTC is connected to these 2 sections, as you can see. After being connected to these 2 sections, our PTC is placed inside the windings of our 3-phase load, whether it's a motor or a transformer. But if you notice, these sections are closed in our model. So ours is not a model where you can connect a PTC from the outside. So we won't be seeing the ones with the dashed lines. For our model, we'll see the other one. If we place the other one side by side like this, let's do it this way. Now we are connecting the 3 phases to the L1, L2, L3 sections below. On the far left, we have our neutral point. As you can see, we will connect the neutral coming from the grid here. Here, there are 2 common terminals, and you can see the open diagram here. 2 common terminals. If you pay attention to the 2, power has been supplied through the buttons. The output has also been given to the contactor. Where is the output given from? It is given from the 3rd end. This is the 3rd end. The 3-phase terminal is normally on an open terminal. If we apply 3 phases and connect the neutral here, the contact here will close itself. What will happen when you close this? If you supply the output to any contactor's coil, then when the relay is active, the contactor will also engage, and the motor you connect to it will start running due to any malfunction. Or the phase neutral voltage is 20% because that's how it's written in the catalog. You can download it from the internet and take a look. If there are voltage fluctuations between phase and neutral of 20%, meaning if it's around 40 volts below or above 220 volts, this relay will take the motor out of the circuit. Or if there's a fault in any one of the 3 phases and the motor is left with only 2 phases, this relay will also disconnect, meaning it will take the contactor out of the circuit. By opening this contact, the contactor is taken out of the circuit and the load connected to it is also disconnected from the circuit. If you want, let's implement the application in this diagram together in our setup and try to see if the motor gets disconnected in case of any phase loss. Yes, you might remember our small panel or work set from our previous videos. Now, let's focus on this area first. If we look at our diagram, we'll provide the link to this in the description. You can download it from there and use it yourself. For testing purposes, we will connect the neutral directly to our leftmost terminal. We will take the 3-phase directly. We will connect to the lower L1, L2, 3 section. I took my 3-phase from this fuse. I also took my neutral from this terminal with the yellow wire. Now I will connect them and continue with my video. Yes, friends, I connected the neutral with the yellow wire. Look, it's at the very beginning. I also took the others to the 3-phase. In this way, I entered 3 phases. 1, L2, L3. When I applied the 3-phase, the signal lamp lit up. The relay has switched positions. Check if it's switched by measuring. So, right now, the relay has switched positions. If you want, let's check right away whether it's switching or not by measuring. Okay, let me just place my multimeter here. Yes, it looks good. Like this. Right now the contact with 3 and 2 should be short-circuited. It's an open contact. I'm turning off the power. As you can see, the output was cut off because I interrupted the three-phase output and the contact has opened. When I supply power, you will see that the contact closes. 2 and 3 are closed together. 2 and 1 is open. You can also connect another receiver or signal lamp here to set up and enhance your system. The motor is either running or it's out of circuit. Now, if you don't connect the neutral here, friends, let me show you that as well. Look, it's not giving an output. This is important. So if you ask whether we can operate it without using the neutral, it doesn't work. You definitely need to connect this neutral somewhere, right? You'll connect it here. What are you going to do with this neutral wire? You will connect it here. Look, as soon as you connect it, we can see that the output is working, meaning that 2 and 3 here have closed. Now by using contacts 2 and 3, we can operate any contactor and connect the motor terminals to the output of this contactor, allowing us to control the motor as shown. If you want, let's test this as well. If I remove any phase, let me take out phase 3 here. Look, the vehicle completely goes out of service. It's working with 3 phases. Of course, don't do this application like I do. It's dangerous. When one of the 3 phases goes out, the system is completely out of service. And I say the motor will be completely disabled. Yes, if we follow the diagram, let's take a tap from one of the 3 phases. And first, connect it to a stop, as is customary. Then I will enter the start and do the sealing, and I will connect its output to the common terminal of the Ikinolu. I'm continuing with my video after doing these processes. Yes, let me explain what I've done so far. I took an input from one of the fuzz devices and connected it to the start. I've now made the same connection. Even though we said we would take the stop first, I took the start instead. Now, we've taken from the fuzz. I took one input from this fuzz. Start, stop linked via bidirectional buttons. On ends show start, stop. In other words, both start and stop are in one body combined with cores. The ends here are the brown ends for the start and the stop ends. First I took a lot of inputs and connected to the start with this cable, just like in the diagram. I came out from the start and connected to the stop with this green cable. The output from the stop came to the Ikino. We reached the Ikino with this orange cable. Also, I needed to do sealing with the normally open contacts 13 to 14 of my contactor. I took 2 cables, yellow and black. I connected them to the 2 ends of the start. I took 2 cables, yellow and black. I connected to both ends of the start. Now this is what remains to be done. I connected to 2 from the output of the stop. I need to go to the contactor from the terminal 3. I will go to one end of the contactor from terminal 3, that is the ABIS. I also need to connect the other end to the neutral. Now we will take an input from the neutral that I connected to the relay, and we will have the system running. I'm going to do these processes right away and continue. Yes, guys, we've completed this process. What did we do last? I came out from terminal 3. I connected to A1 of the contactor. I came out from terminal 3. I came to A1 with this red cable. I also needed to connect the other lower end, the neutral. Here we had the neutral of our relay. I connected it to the system by taking an input from there. Now when we provide the 3 phases, you'll notice that the system is working. So our relay is working. We need to connect the neutral to provide the output. For the input here to light up, 3 phases needed to be connected. We can see that these processes are complete. Now, when I press start, you see, because we did the sealing, you already know from the previous tasks, the system is working. When we press stop, boom, the system stops. Now, where are we going to connect the motor? I'm going to connect the motor to the output of this contactor. To connect this, first, as you can see, we will connect the 3 phases to the contacts of the contactor. We will also connect the motor to the input or output. There's a thermal relay here, but I'm not prolonging the job by connecting the thermal relay anymore. I will take the 3 phases. I will connect to the contacts. I will continue by connecting the 3 ends of my motor to the output T1, T2, and T3. Yes, in the last section we created the power circuit, guys. We took the 3 phases with this brown wire, the input terminals of the contactor, to L1, L2 or all 3. We connected the 3 ends of the motor located here to the output. Now when I supply power, the system starts up. There's no problem with the relay. When it lights up with 2 LEDs, when I press start, you can see that our motor is running. When we press stop, you can see that the motor has stopped. This is a normal step. Now, while the motor is running, I'm going to remove one of the fuses here. We will check if the relay stops the motor this way. Yes, I did it. This way because I supplied power. Let's say one of the phases is currently gone. If you pay attention, the system is there, but there's no output. When I applied the phase, the system came on. I pressed start and it worked. The phase went out while the motor was running in any way. Look at what the relay does to the motor. It removes it from the circuit. And what have we done to our motor this way? We are preventing it from staying on 2 phases with this relay. You can ask like this: isn't the phase sequence important for the direction of the motor's rotation? It's important. There are also phase sequence relays that you can get separately or that can be included together. You need to buy and use it separately. If you get a phase sequence relay, it removes the motor from the circuit, both when the order of the phases changes and when any phase is cut off. We can't adjust the phase sequence with this relay. We can't make adjustments to the phase sequence. With this relay, what can we do if one of the 3 phases is not in the circuit? Removable from the circuit. Yes, I'm applying the fuzz again. I'm pressing. Start like this. There's no problem in the system. When I remove the fuzz from its place, I say that the relay takes the motor out of the circuit and removes the receiver from the circuit. I hope this video has been useful for you. If you have any questions, you can send them to our email address for urgent questions. Comments are not appropriate for this topic because I wish you all successful work without any accidents or troubles. Regards. Have a good day.